Let's start. Dobry den, good morning. We are here to attend a talk about clean code and monsters, heroes, and victories. So I want to talk about a very common topic, but with a little bit of fun. Hope I can get it to you. If you want to ask questions, this is the page, Slido. GeeCON is the tag, and room 6. I want to start with a huge number, that it is $2 trillion. That is the cost of poor quality code only in United States. This is, at least for me, a lot of money. But if you are not concerned about money invested on poor quality code, for sure you are interested on time. So 4 days is the time per month and developer spent on fixing errors. I hope that now I have your attention, and let's go and talk about clean code and if it's really worth it. I'm Jonathan Vila. I'm Java champion, also one of the leaders of the Barcelona Java user group, and co-founder of the conferences JVCN and DevVCN. Have anybody of you have ever heard about DevVCN or JVCN? Great. For the rest, check it out. Barcelona, summer, awesome. I have some speaker experience. This is my first time at GeeCON, my first time in Prague. So long, I'm enjoying a lot. Thank you. I've been developer for more than 30 years. I started using Pascal, C, but also several other languages. But my preferred one at those times was Delphi. Has anybody used Delphi before? Great! And lately, Java. Also Go last year, but yeah. I've worked for several companies, as I said, but the last ones are Tetrade, a small company in US, Red Hat, not that small, Okada Technology, and Netcentric. But now I'm developer advocate for Sonar. Has anybody know about Sonar? Sonar Source, Sonar Cube? Well, I think I can just go and that's it. If you want to contact me, just scan the QR and you will find more information. Few words about my sponsor. Sonar is a company that provides technologies and methodologies for clean code. You can find these free tools, SonarLint, that it is a plugin in the IDE that will help you to use, to get clean code. SonarCube, that is also open source tool for gathering information about several projects. And Sonar Cloud, that it is the hosted version and free if you're using open source projects. If you want to know more, just ping me or just go to the website. So here is the QR for the slides. If you want to check them out as I'm talking, fine. And the agenda, well, first I will introduce you, which is the definition of poor quality code, the cost of it. I introduced it, but we will see a bit more. So if we know what it is poor quality code, then what it is clean code. Few recipes that can be interesting. Some of them are very basic, but it's nice to remember all those things. That most detected issues. So with our tools, we are analyzing thousands of projects, and we have telemetry of those projects. So I will show you the most detected issues, and probably you will be surprised for some of them. Interesting hints about Java and clean code, tools that you can use in order to go towards clean code. The way, in this case, I'm going to follow what my friend Mando, is anybody following Mandalorian? 3, okay, 4, 5, okay. You're shy. Okay, so this is the way. So in this case, I will show you which is the way to be to clean code. Some references if you want to check more deeply the content. But first, I'm going to introduce which is the monster of this talk. This is Porky. I tried to find a cool name about this monster. This is the monster that represents the poor quality code. And Porky, so which are the attributes of Porky? Basically, exhibits buggy behavior. So it's an application that is going to fail from time to time. messing with high coupling and low cohesion, so having domain objects scattered across the code, and also classes depending on other classes, so it's hard to modify one. And maintainable, because every time that you want to fix something, you are not confident. I am fixing this and breaking that. So that's another point. It's using obsolete libraries, versioning. Who cares about versioning? Well, we should care. So versioning implies a lot of improvements and security. It has a lot of code repetition across the code. So every time that you want to improve, I don't know, the way you connect to a database or a service, you need to change this code in a lot of places. Therefore, you are changing only some, and other parts of the code remain without being touched. But this is only it about Porky. Yes, it is more about it. It is susceptible to common vulnerabilities and exposures. Why? Because you are not checking that you are introducing libraries that are bringing CVEs. Therefore, well, your code will suffer from those CVEs. Even your code can have, introduce these CVEs. It can be prone to memory leaks and low throughput because you are having classes that are doing more things that are needed. And as it is everything like a spaghetti, you remember that famous image? You have a spaghetti thing, and sometimes you are not releasing resources. Therefore, you are having more memory consumed. Has anybody suffered from non-releasing resources? Okay, only you and you. Okay, okay, you're a bit shy, right? Okay, so non-deterministic results, because as you have several classes that are connected and that they are doing a lot of things, when you try to do one thing, there are side effects that you were not counting with. So it could be that those side effects are impacting in your results. Because it's everything connected, you have a lot of responsibilities in the same method, class, whatever. It's hard to create good testing. Because, yeah, you cannot isolate features that you want to test. Once you call a method, you are doing a lot of things, and it's hard to test only a particular feature that you are going to test. Therefore, it could be that in order to make tests, there are use cases that you are not covering because those are the most complicated ones, or it's hard to implement. So this is like creating the iceberg image of the tech debt. So we have a lot of things to do. So, but yeah, we are in several projects, we are doing this. So what is the real cost of everything? Well, as you can see, the cost of poor quality code is more than $2.4 trillion. Remember, only in USA. But only finding and fixing bugs, it's more than $600 billion. It's a lot. You have here the link. This is the report for 2022. It's a lot of money invested on fixing bugs. So now, following the chart, it's clear that the healthier the code is, the less number of defects, therefore, less money we are going to invest and time on fixing them. Are you all clear about clean code and the benefit, or at least the lack of benefit? Okay, it's morning, okay. But it's not everything lost. So we have one hero. In this case, it's called clean. But basically, the hero is you. All of you are the heroes that are going to solve this problem. So now you can feel like a hero solving or fighting Porky. 3 heads. Well, let's see how many heads can you cut. So our hero does in a regular day. I have to say that I haven't been that happy ever. But okay, it can be. It can be. What our hero, you, do in a regular day? Well, introduce new features because we are paid for doing that, right? Fix some bugs. Yes. we have little time for tech debt fixing. So I want to ask one important question here, and don't be shy. How many of you have a lot of time to fix tech debt? Okay. How many of you have one sprint, I don't know, a quarter, a year to fix tech debt? Okay. How many of you have very little time to fix tech debt? Okay, you win. So, and also another important part of you, our hero, is that you study new technologies, you check online videos, you check trainings, and you go to meetups. Who regularly go to a meetup? No, come on. And the rest? Netflix? No, go to a meetup. It's the best thing that you can do in your professional life. Go to a meetup. So you go to meetups and you go to conferences, and that's why you are here. This is super, super, super important. Probably you are not aware of the importance of being here. And also, talk to others. It's super important. Community is first. But also, you go to several meetings. At least I do. And most of the time, I'm told you're on mute. Yeah, I know. I don't learn. But also, for sure, you rant about all code. Probably nowadays, you are not using that monitor, CPU, and keyboard. I did. But the most important thing of this GIF is that probably he's ranting about a very shitty code until he does the blame, and he was himself who introduced the code, right? It's also an important part, this. So which is the nirvana of our heroes? So let's say you, which is the goal that you want to get in your professional life? So first, let's talk about the software, the nirvana for the software. So it has to be secure, yes, obviously. We don't want to suffer from CVEs, attacks, and so on. Maintainable, again, it's easy to add features, to refactor, to improve. Reliable, because it is doing what it is supposed to do. And it's portable, so you are reducing the dependencies with hardware, with libraries, so more focusing on concepts more than specific libraries. But which is your nirvana? This is also important about clean code. This is not only about software, it's about you. So you need to be confident about what you deliver. So it's like, I'm going to do a feature, and I don't want to be nervous when it is already in the pull request, and I'm going to find some of my colleagues saying, come on, you didn't do this, you didn't do that. So you want to be confident about what you are introducing. Proud, because again, you are going to deliver good and clean code. And you will see lots of emojis in your pull request, and those look good to me from several colleagues. And also you want to be skilled. You want to improve every day, to learn new technologies, to be more available for the market, right? So our hero heard about the Clean Code Warriors Order. And she decided to join. Yeah, she was nominated as a knight, I don't know. And the principles for the Clean Code Warriors, first, you need to consider security in your code. Don't repeat yourself. You need to abstract things. Yeah, this emoji, I'm gonna need it. Yagni, sure. It's like, we've done this several times. Yeah, let's do this, and let's use this technology, this library, because one day, we are going to change the database. At least for me, that never happened. Let's use an ORM to change database. Yeah. Okay, so it has to be readable and explanatory naming. It's not about, so we spend more time reading than writing. So it's important that you write code with the right naming. It's clear for everyone. You need to reduce cognitive complexity. I will come back to this concept. For sure, you're more familiar with cyclomatic complexity, but we will talk about that later. Boy Scouts, just please, if you see code that it is easy to fix, yeah, I know it's not on your feature, it's not on your issue, but you can fix it, you can improve it, do it. Boy Scout. Solid, well, the basic principles that we all know. Your code needs to have the good tests, so the right test coverage, but also good tests. It's not about just testing, it's about having the right test for each case. Basically, don't over-engineering your solutions. It's not about showing to the rest of the team how amazing you are, doing crazy things with lambdas. And if it's easier, just use a loop. That's it. It's easier. That hit me when I changed from Java to Go, because I didn't have streams and I had to use loops, and it was perfectly fine and definitely the way to go in Go. So it was interesting. Basically, wash your hand, because you are using your hands all day long with your keyboard. That's important. And the most important principle is use common sense in everything. It's the most important principle. So let's see some of the fighting tricks that our hero has been trained. First, dry, so don't repeat yourself. So you have here on the left repetition of how to get the user to connect to a database, abstract the method. That's easy. Keep it simple, and you ain't gonna need it. In this case, yeah, we need to do operations with numbers. Okay, let's create a calculator. Why not? Okay, we create the calculator, and then the only operation that we do is summing two different numbers. Do the sum, and whenever it is needed, do a thing. Boy Scout, again, if you find arguments not used, we will see that it is very common, this issue. You have arguments not used, variables not used, remove them. Single responsibility. Well, we have here an entity that it is a book. It is an entity. It should be an entity, a record if you want. Why it is having a print method accessing a standard output? No, just single responsibility is important. Open-close principle, yeah, is open to extension, close to modification. In this case, we have a vehicle that has a motor that, yeah, we started this thinking, yeah, there is only one way of having a motor. So it's an engine that it is doing the combust operation, but then a hybrid engine or an electric motor appears, and we thought, yeah, let's add more types in the same class. Yeah, no, use interfaces and abstract to that, and then you will be able to implement the specific cases. Liskov, when you need to replace children with parents, so children are not overriding parents' behavior. In this case, we have a person that have a method to pay, but then we have a kid, and it's not common that kids are able to pay. But then what we are doing is, yeah, okay, for the kid pay method, we are going to raise an exception. That's not correct. So just simply create the right interfaces, a person, and then have the abstractions, and then create a person, then an adult, then a kid. Well, you know, you understand the process. Interface segregation. This is very important for me because I'm a super fan of the Sharknado series. I've seen them all. And the best one, no, the worst one is the last one. So in this case, we have an animal that can breathe, fly, swim, and move in space. Yeah, for a dolphin, we can implement the breathe, we can implement the swim, but not fly, and definitely not move in space. But for a Sharknado, we can implement them all. In the sixth movie, they change and they can move in space. Perfectly fine, right? So let's use the interface segregation and implement those interfaces that are right for your use case. Dependency reversion, instead of depending of direct implementations, depend on abstractions or interfaces. So in this case, we have a book and we have a shelf that contains books, but then if we need to contain also CDs or other things, we need to modify the class. No, just depend on the abstraction and that's it. And about naming, it's clear, it's important, we all understand, we all know, but then a lot of issues are introduced in code. I've seen it. Using variables with one letter or one or two letters. And when you read it, it's super complicated to understand the code. We are not paying by characters. So you are going to pay exactly the same for a 2 characters variable than for a 10 characters variable. So our hero, you already know which is the monster. The principles has been trained. But then before leaving just to fight Porky, she wants to know how it is, the status report of casualties out there. And the most detected issues from our tools have been, well, 14 million times, the cognitive complexion of functions is too high. There are lots of unused assignments that should be removed, 14 million times. Unused local variables, same, not used. A lot of to-do tags. A lot. 13 million. Yeah. Yeah, a bit less. Yes, 1 million less, sure. Also, unused function parameters. Again, we create a function with 10 parameters and then we only use 2. Row types, in this case, when you are using generics, sometimes you are not specifying. You, I mean we. We are not specifying the specific type in the collection, in this case. So it's better to use the specific type. Private fields that are not used. Generic exceptions instead of specific exceptions for your use case. Local variables that are assigned and then returned instead of returning directly the value. Private methods that are not used and should be removed. Null pointers not being checked. And methods that are should not be empty. This is, I don't know, when I saw this, I thought 9 million times a method is empty. Okay. So I grouped them into complexity, dead code, design, error handling, and null handling. Most detected security issues. So basically, we should have secure algorithms in order to create passwords to connect to databases or services. In this case, we are not using the right way to encrypt a password. XML parsers can suffer from execution injection. Endpoints that are vulnerable to cross-site attacks. Credentials that should not be hard-coded. So there are lots of projects with passwords hard-coded. And there are some GitHub scrapers that are going to GitHub, check repositories, and get passwords for those things. So do not hard-code passwords. And in this case, we are using a value coming from the user and accessing our file system. And then, yeah, this can lead to path injection attacks. So it's like credentials and injection. So basically, the summary is that we have a lot of dead code in the projects with a lot of parts being about complexity, to-do blocks, error handling, null handling, and vulnerabilities. So now our hero has been trained, knows how it is out there, and then she decides to go to the Grandmaster and learn new tricks. So the Purple Ninja, I don't know, have anybody of you watched the Purple Ninja movie? Search for it in YouTube and you will be surprised. So vulnerability and security challenges. I don't know, one day I will have to try this. Multas means fees, I don't know, the way, the table. So SQL injection in this case. So basically, credentials should not be hard-coded. Again, there are a lot of projects with hard-coded passwords. We should use third-party services to store those passwords for us. Database operations queries are can be vulnerable to SQL injections. In this case, you are using a string concatenation instead of using prepared statements and then setting the value for the prepared statements. HTTP redirections, we are using a value coming from the user in order to do a redirection. In this case, what we should do is sanitize this, just checking the list of available redirections that we allow, and not just simply doing the redirection. Regarding bugs and code smells, I assume a lot of you are using a Spring framework? No? Okay, and the rest that you are not using? Quarkus? Micronaut? Helidon? Check for them. Ahead of time compilation, great thing. Okay, so if you are using a Spring Boot application, just use it in a class that has a package, because Spring will scan all the beans starting from that package and below. And if you don't specify the package, it's going to scan the whole class path. So someone could just simply inject a jar there. Wait, so when you have threads and a synchronized method, therefore you are blocking. In this case, if you need to pause the thread, don't use the thread sleep because it's effectively blocking that thread. Instead of that, use the wait method, and this will not block the thread and use it for other uses. The printf style format, it's very powerful because yeah, it's easy to introduce strings and values, but sometimes it's hard to point that you missed one argument, or that you are putting one argument more than it is needed, or you are putting in the string the wrong type. So it's important to check all those things just to not have unexpected behaviors at runtime. This is also an important thing, and it happened to me once. You create a test without testing. So you create everything, and you forget to add the test condition. The method will pass. The test is green. So you need to be sure that you are not missing any test in your tests. And again, the test should have assertions. So those are combined, right? But it's important because if you have lots of tests and you have a lot of code that you want to submit, it could happen that you miss one of them. This is a Java 19 hint. If you want to create, in this case, hash-based collection with defined number of elements, if you use the constructor, it's not guaranteed that you are going to have all those elements at that moment. It can go by groups of elements. So if you specify 1 million, probably it will get 1,000, and then the next time it will get 1,000 more, and so on. Instead of that, if you use the static method new hash map, then it will guarantee that you have all the number of elements. Regarding the design and complexity, now I will explain what it is cognitive complexity. In this case, we have two methods with the same cyclomatic complexity, 5. Who thinks the left one is the easier to read? who thinks the right one is the easier to read. But the number is the same. So we have something here that it is not correct. But now we have the cognitive complexity, that it is not only considering conditions and breaks, but it's also considering indentation and other elements. So now we have, instead of 5 for the left part, we have a cognitive complexity of 9. And for the right part, now we have a cognitive complexity of 1, because it's very easy to read a switch case. So now we have a clear definition of what is complex, and then we can set in a quality gate that our code cannot be more complex than 5. Then we need to refactor this part of the code. This is also very basic, but it happens sometimes. You need to take care of the number of dependencies that your classes have. If you have more dependencies, everything is going to be harder. This is also a very basic one. Method should not perform more than one task, responsibility, whatever you want to call it, in order to be clear what every method is doing. So instead of having a giant or brain method, just refactor it and split it. So in summary, there are lots of things to do, a lot of things to take care, a lot of things to remember. It has to be you who is taking care of all of these things every time that you code and when you are reviewing others' code. And for every commit that you are introducing, and for every pull request that it is being created, for the full project or for the new code. Let's see which is the right approach. So which are our weapons? So the weapons for our hero, so you, we have static analyzers. They are going to analyze your code using, I don't know, PMD, SonarLint, checkstyle. Well, you see some of them. And they will check for correctness, for security issues, for vulnerabilities. So they will check your code, considering all the things that we have talked about, but yes, for you. So every time that you code, you will see warnings and issues, considering all of the things that we talked before. With the IDE linters, well, as you are coding, you have something that it is going to highlight issues in your code, and you will learn from them. We will see here we have an unused variable, but on the right, we have the explanation. Why is this an issue? Okay? And in the CI environment, we need checks that prevent bad code to be merged into the main branch. So with quality gates, we are going to define which are the thresholds of bugs, issues, vulnerabilities, even coverage. And those quality gates are going to ensure that the code is fine. The important thing here is that there are like 3 focuses. First, clean as you code, because as you are coding, you are seeing all the issues that you are introducing. I have a saying for this, that linters are the same as Las Vegas. What happens in your IDE stays in your IDE. So in this case, if you use a linter, you are going to be warned before you commit. So that's important thing. So being more confident than if your linter is not saying anything, then you are more confident that the code is going to have like a good review. But also, another important point is that we don't have to use linters as a black box, that they are simply auditing our code. So if it warns me, I fix it, that's it. No, it's learning. So we are introducing issues, and we can learn. So in here, this is an example of SonarLint, obviously. But here you have the long explanation of why that is an issue, and the ways you can solve it, or reduce the impact of this issue. And this way, you are going to learn and be a better developer every day. And also for team retrospectives. So when you share all those issues that your linter or your system highlighted, then the whole team can learn about those issues. It's not only about fixing, it's about also learning. But then there's another thing that we need to consider, that it is an unexpected danger, that's false positives. So we can have information overwhelming. We can have lots of issues. And for some of them, we can say, okay, this is not really an issue, but the linter or the analyzer doesn't have like the whole context to distinguish between an issue or a non-issue. In this case, for instance, this would be an issue if we use the log method and we use a string concatenation. We should use the parameters, the arguments of the method. But as you can see here, this const value is resolved on compile time. So in runtime, we are not going to have string concatenation. So this is really not an issue. So we can, with this kind of tools, we can define those issues as this is a false positive, and then they will not annoy us in the future. This is also an important point if you want to consider different tools. Check which is the false positive ratio. So now that we have like heroes. We have the monster, the tricks, the principles, the hints. What do we need to do? Which is our voyage. So basically, we need to do clean as we code. So focusing only on new code. Because we will see now in a minute, code is like everything alive in Earth. Code dies. So eventually, your code that you are introducing today will die, will be removed in a few years. More or less 20% of the code is changed every year. Therefore, there's no point on focusing on old code that it's creating this overwhelming feeling. Focus only on the new code that you are introducing, and after 5 years, almost all your code is going to be clean code. You can define clean code as from the previous version, from a number of days, or a specific analysis, or even a reference branch in a pull request. Okay, sometimes do not forget to use the Boy Scout principle and fix small things. But it's not about fixing old fires, just focusing on new code. Here we have like the images from Git of Theseus, that it is based on a story, the ship of Theseus. It's a ship that every now and then was having a piece replaced by a new one. So after several years, there was this discussion between people that didn't have to work at that time, if that ship was the same ship. So we have replaced every piece of it with a new one, but now the ship is the same or not. With this principle, well, you can check in GitHub, Git of Theseus. And here you can see for a given project that the code introduced in 2012 almost disappeared in 2022. Well, 2018. So all the code introduced, you can see that it is being deleted after some years. So don't focus on old code, just focus on new code, and this will reduce the friction to adopt these kind of tools. So with all those, all this information, what do you think is the approach to follow? Remove all issues today and kill Porky? Or clean as you walk and only one head at a time? Who thinks is kill Porky now? And who thinks is cut a head at a time? Perfect. Yeah, definitely. So my conclusions for this presentation is not using clean code has a huge impact, but not only on software, but also on morale of the team, and even for reputation, company reputation. So this is also very important. Developers, well, in majority, you don't have enough time to invest on fixing bugs, tech debt. Obviously, clean code will have a positive impact on software and developers, as we've seen, but there are a lot of things to consider. Just only considering our tool. For Java, we have 665 rules, only for Java. And if you also have deployment artifacts, YAMLs, in your project, we have, like, if we cover Terraform, Docker, Kubernetes, we are having around 100 rules. So you need to think about all of those rules. Some of them are tricky in order to be clean code. So why do it on your own if you can have a tool that help you? Several tools can help you on the IDE or even on the CI. You can start, in this case, using open source tools like SonarQube. You can download them, run them, free, that's it. And then you can move on if you think it's needed. Only a portion of the code will survive across the years. So there's no point on focusing on old code, but focusing only on new code. And AI tools can also help you in some cases, okay? It's important to use them properly, to scaffold code, to create boilerplate code in order to save you time. It's a good option. Here are the references if you want to check them and know more about them, about all the topics. I need to thank all the AI image generation tools that I've used to create this presentation. If you have paid attention, there are people with 3 hands or more than 5 fingers, but yeah, that's okay. Hallucination, they say. Leonardo, amazing tool, ClipDrop, or Firefly from Adobe. And that's been all. I want to also give thank you to the characters of this presentation, George as Porky, Lydia as Clean, and Jibman as the master, and me as the voiceover. Thank you very much. Please scan the feedback, rate me, even if you want to give me very bad rating. I will learn a lot from it. Also, if you want to check the slides anytime, it's been a pleasure to be here. Thank you very much.